Hello. In this problem, I want to graph f of x is equal to negative parentheses x minus 3 close parentheses squared plus 1 using transformations. And it says clearly indicate the final graph. Now, since I'm only going to be graphing a single graph on the coordinate grid, I don't really need to worry about that so much, but I do need to use transformation tables to get me there. Ask yourself, what's the parent function for f of x? Well, because this is a quadratic, its parent function is y equals x squared. And I'm going to do the table for y equals x squared. Notice that my x values will be negative 3, negative 2, negative 1, 0, 1, 2, and 3. If I square each of those, that gives me 9, 4, 1, 0, 1, 4, and 9. And then I'll work left to right. This negative is a reflection across the x-axis. But for the table, it doesn't really matter that much. But what you should realize is that this negative is on the outside, and there's an understood 1 right there. This means that I take this negative 1 and I multiply all of the y values by that negative 1. So I'm going to multiply y by negative 1. I'm going to use a different color here. And this gives me y equals negative x squared. And so this is going to give me a new table. So I'm going to have my x's stay negative 3, negative 2, negative 1, 0, 1, 2, and 3. But all of my y values will change to negative 9, negative 4, negative 1, 0, negative 1, negative 4, and negative 9, because I simply multiplied each of these y values by negative 1. Next, we're going to go to this positive 3. Excuse me, this negative 3. This negative 3 is on the inside of the parentheses, which means it directly affects the x value. And so I need to do the opposite of what it says. Now this says minus 3, so I add 3. So I'm going to add 3 to the x values. So this is going to give me y equals negative parentheses x minus 3 squared. And this gives me a new table because of this. Because I'm adding 3 to x, that means that my y values will all stay the same. So I still have negative 9, negative 4, negative 1, 0, negative 1, negative 4, and negative 9. But I need to add 3 to all these x values. So negative 3 plus 3 is 0. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2, and so on and so forth. Next, I go on to this plus 1 at the end. Because it's on the outside, I do what it says. So it means that I add 1 and it's on the outside, so I do it to the y value. Therefore, I need to add 1 to the y's. So that gives me y is equal to negative parentheses x minus 3 squared plus 1. And this gives me a new table. And because I'm doing this to the y values, my x values will all stay the same here. Therefore, it's all still 0, 1, 2, 3, 4, 5, and 6. And yes, that is a 5 and 6 there. There we go. Somehow make that look like 5. There we go. Now I need to add 1 to all of these y values. So that's going to give me negative 8, negative 3, 0, 1, negative 3. Ooh, I've messed up here, haven't I? Negative 8, negative 3, 0, 1, excuse me, that's a 0 here. There we go. negative 3, and negative 8. And these coordinates are what I'm going to graph. So I'm going to start out with 0, negative 8, then 1, 2, 3, negative 3, then 2, 0, 3, 1, 4, 0, 5, negative 3, and 6, negative 8. And you should be able to see your parabola there. There you go.